Hi, I'm Adam Pritchard, Assistant Curator of Paleontology for the Virginia Museum of Natural History, and I'm back with another tale of ancient life. And it's been a busy week here in the paleo area of the VMNH. We've been removing and rehousing a lot of specimens in preparation for the receipt of some new and very exciting specimens, especially from the early age of reptiles for our fossil preparation lab. So some exciting stuff coming up. We're also getting ready for a field trip to the far southwest of Virginia to an ancient forest environment from over 300 million years ago. So, yeah, lots of new tales to tell. And moving some specimens around, I thought it would be cool to share some of our odder specimens. If you take a look at this little slab here, you'll see that there's sort of a lump on the rock. And that's sort of the impression that one of these fossils leaves. And if I spin it around, you'll see the specimen itself. Exciting, right? A big round blob of black material. So this is not a bone. It actually might contain some bones, but this is what we call a coprolite. A coprolite is the technical term we apply to fossil fecal matter or poop. These come from the Solite Quarry. This is a site that's famous for producing fossil insects and the early reptile Tannytrachelos, long-necked weirdo that I've talked about a couple of times. And it might surprise you that this stuff can survive the fossilization process. But the contents of, fossil feces often contain very hard materials. Plant materials like stems and leaves all ground up, bone in the case of some reptiles. And in the Solite Quarry, a lot of fossil poop sank to the bottom of the same lake that contained the Tannytrachelos, the fishes, and the insects. And although it hasn't been studied as intensively as the fossil skeletons and insect material that we have from the Solite Quarry, I think the fossil poop from here has some interesting potential to tell stories as well. Now I'm going to vacate the recording area and turn things over to our most dedicated paleontology lab volunteer, Alicia Lantz, who's going to show you some of our coprolites from the Hell Creek Formation, about 68 million years ago in late Cretaceous of Western North America. It's this area that generates fossils of T-Rex, Triceratops, duck-billed dinosaurs, and coprolites.
I find dinosaur coprolites interesting because they're the end product of the dinosaur's digestive system and something that you don't typically consider when thinking about dinosaurs. I have two examples for you here. There are many things that can be learned about a dinosaur's diet by examining the coprolites. For example, in this coprolite, we see a piece of bone right here. And that indicates that this dinosaur was a carnivore, a meat eater. And in a similar way, if you were examining a coprolite from a plant-eating dinosaur, you would expect to find some evidence of plant material in the coprolite. And this funny-shaped piece kind of shows that this coprolite was pinched off by the muscles at the end of the dinosaur's digestive system. So examining something like a dinosaur's coprolite is just one of the many reasons that I find paleontology so fascinating, that I can be so close to these things from dinosaurs of the Cretaceous period that lived so many years ago, but yet we can still examine evidence of them today.
I hope you've enjoyed this short window into the world of fossil feces and coprolites. Look forward to sharing more tales of ancient life.